Cool. So, our next question that we got to cover is find the equations of both lines that pass through the point 2, -3, that are tangent to the parabola y equals x squared plus x. So let's dissect what we need to know from this question. So original function equation is y equals x squared plus x. And the point of interest, let's call that P, and that is at 2, -3. So that's the x value and that's the y value. We're going to be dealing with rectangular coordinates here. Okay, so we got to find the two tangent lines intersecting with point P. Okay, so first let's do a little analysis of what we're going to see on our original function equation. So we see that the leading coefficient for the x squared term is +1. Since it's positive, we know that this parabola is going to be opening upwards, kind of like a cup type shape or a U type shape. So something like this. We're going to have a point P somewhere. This is just to get a rough idea. We don't necessarily need like super detailed diagrams. But you see how we're going to have two tangent lines that intersect with this. One of them is going to be like on this side. I'll draw that, like, maybe I'll start that from here to show that it, like, one will be from this side. Will be like a negative sloping type of tangent line. And the other one will be like pretty vertical, but like you know, like the parabola would keep going, and then somewhere up the parabola there would be some point where the tangent line does intersect with this. So we are definitely going to have two lines that intersect with it, only two lines. So yeah, cool. Let's find those lines. So we know that like y is equal to x squared plus x. To find the tangent line at a certain x position of this, we need to find the derivative, right? So let's find the derivative of y with respect to x. So let's call that y prime. Y prime, well, the derivative of this, we bring the 2 down, we subtract 1. So we got 2x for the first term, 2 times x. The second term, the derivative of x on its own is just its coefficient, which is 1. So 2x plus 1. Super. Now, we know that the line that's going to intersect, like be tangent to the parabola and also intersect here, we know that you can find the slope of any line if you have 2 points in that line. So let's say we have this point, or it could be that one, but I'll just focus on this one here. Let's say that we have like, this is like AB. Knowing point AB, or knowing point with coordinates AB and knowing the position P, we can find the slope there. And the slope on that connects those two has to be identical to the slope that we have on our derivative, right? Because the tangent point at this point is going to be a slope with a certain, or is going to be a line with a certain slope. Okay, so let's find the slope between any point on the parabola and point P. So we know that like AB is going to translate to like x for the x coordinate, and then the y coordinate is going to be x squared plus x. That's the legitimate formula for how we calculate our y coordinate given our x coordinate. And then our point P has coordinates. The coordinates are 2 on the x and -3 on the y. So let's find the slope between these points. Of course, this one is not an actual point, but this gives us any and all points that are on the graph. Slope between the points. Okay, so the definition of slope is rise over run. Rise is like y2, the second y, like its destination, minus the y component of its starting point. And we got something similar for our x. So we have the x part of our finishing point minus the x of the initial point. Let's sub in our points here. So our second point, like let's say we're looking at this one, we're starting at to the left of point P and then we're going down to the right. So let's say like this is our y, like this is our x1, this is our y1, and these will be like our y2 and our x2. Okay, so let's sub those in to our little equation. So for y2 we got -3. Here we have 2. And then we're on the top we're subtracting x squared plus x. And on the bottom it is just x, which is the departure point. Okay, so this is the slope of the point of interest P with a point there. But that slope has to be equal to the derivative for it to be a tangent line. So how about we just set this whole thing equal to 2x plus 1, which is the derivative. Okay, with some quick maths, let's expand this all out. Equals -x squared, because you see the negative here multiplies into the x squared and is also here. So it's -x squared minus x minus 3. Wow, the top is very negative, but that's nothing to be worried about. And the bottom is 2 minus x. Okay, let's multiply both sides by 2 minus x to get rid of this denominator, put it to the other side. So we got 2x plus 1. And we have 2 minus x. Then we have minus x squared minus x minus 3. Okay, cool. Now let's expand out the left side. So we have 2x times 2. So that's those two. And we got 2x plus 2x times minus x. Then we got plus 1 times 2. And then we got plus 1 times minus x. Equals this. But I'll clean this up to make this easier to read. So this is the only x squared term. So we're going to have negative 2x squared. Combine the x terms, so we have 4x and then minus x. So that's going to be plus 3x. 4 minus 1 is 3. Sounds about right. Plus 1 times 2 plus 2 equals negative x squared minus x minus 3. Looks like we could simplify this down to a single quadratic that we can solve for x. So how about we do that? Let's set the left side equal to 0. Then we're going to have to add 2x squared to both sides, so that's going to be positive x squared. Subtract 3x from both sides, so that's going to be negative 4x. And we're going to subtract 2 from both sides, negative 5. How do we figure out what x this is? It's hard to factor it out because, you know, the last digit here, 5, that's a prime number. So we're going to need to use a quadratic formula. Actually, no, never mind. Negative 5, or, okay, I'll write out what I'm trying to say here. So we have like x minus 5, and then x plus 1. That's what I mean that we can get this. So essentially to get here, we need to find 2 digits that multiply to get negative 5 and add up to negative 4. That would be a combination of negative 5 and 1. Multiply them together, you get negative 5. Negative 5 plus 1, that's negative 4. So these two are equivalent to each other, which means that our points of interest are x equal 5 and x equals negative 1. These points have tangents intersecting P. Okay, but the question says we need to find the equations of both the lines that intersect with the point P. So to find out where those tangents are, that's not enough. We need the complete equation of the tangent line. So I'll slide over here to just get a little bit more space. Our original question is, or our original equation, y equals x squared plus x. We are basically now looking for tangent line equations at x equals 5 and x equals negative 1. So to find the tangent line equations, that's fairly simple. It's just we had to find the x equals 5 and x equals negative 1 originally. And we did that through the process here. I'll review that at the end. Okay, cool. So to find the tangent line equation, given this, first we need the derivative. We already calculated that previously. Y prime is 2x plus 1. So how about we sub in x equals 5, y prime of 5 equals 2 times 5 plus 1, which is 10 plus 1, 11. Beautiful. Okay, so we know that we know that's the slope at x equals 5. Cool. So we know equation of a line. That is y equals mx plus b. Also, we have a point P. which is 2, and negative 3. Okay, so we can use the point P to sub in for our y and our x. We found our m, which is our slope. That's 11. We just need to now solve for b. So once we sub in everything, b is the only unknown, so we can easily solve for that. Let's first isolate b. So b is equal to mx minus y which is equal to 11. Multiply that with 2, and we're getting that from point P. We're subbing in point P, 2 for x, negative 3 for y, minus negative 3. B, 22, I don't know about you, I'm feeling 22, plus 3 base is 25. Okay. So equation of this line would be y equals 11x. Oh, oops. See, this should actually be negative 25. You see here, I rearranged wrong. This should really be my bad. I'll clean it up. You know, mistakes can be made sometimes. Just don't repeat them. Mistakes don't make you dumb. Repeating mistakes makes you dumb. So this is actually y minus mx. So y we had negative 3 minus 11 multiplied by x, which was 2. So we got negative 3 minus 22, and that is negative 25. So our b is negative 25, and our equation here is 11x plus b, and b is minus 25, so we'll just put that here. One of the tangent line equations at x equals 5 intersecting at point 2, negative 3. Okay, so that would be one of our final answers. So we did for x equals 5. Now let's handle the case when x is equal to negative 1. So we're largely going to follow the same method that we did for x equals 5. So we're first going to do y prime with a negative 1 for x. So our y prime equation is 2x plus 1, which is equal to x is equal to negative 1 in this case, plus 1. So y prime of negative 1 is equal to negative 2 plus 1, negative 1. So that is slope at x equals negative 1. We know equation of a line. That right there, y equals mx plus b. Isolating for b, because we know y and x, that gets subbed in from our point here, 2 for x, negative 3 for y, and our m in this case is negative 1. So we just got to solve for b. And we'll do it correctly this time. Y minus mx, not the other way around, which I previously mistaked. Okay, so let's math this out. Y is equal to negative 3 minus negative 1 times the x, which was 2, comes from point P. Okay, so we got negative 3 plus 2. B is equal to negative 1, which would mean that our equation here would be y equals negative, well, our slope was negative 1, so we just do negative x, plus b. Our b is negative 1, so that's going to be minus 1. Cool. And this would be our second version of a other tangent line equation at x equals negative 1 intersecting at p 2, negative 3. Cool. How about we put these on a graph to confirm that we did this correctly? So I'm going to pull up on a new slide here. I'll do Desmos. Pull up the graphing calculator, Desmos. Gotta love Desmos. Graphing calculator. So let's put our first tangent line equation in. 11x minus 25. Our second equation, minus x minus 1. Hey, let's see if they intersect at the point 2, negative 3. Oh, would you look at that? Would you look at that? That's cool. Our original equation was x squared plus x to the power of 2 plus x. That looks pretty tangent to me. And it's intersecting at our point of interest. So the blue line, y equals negative x, minus 1. That looks pretty good. Our red line corresponds to 11x minus 25. Hey, that looks pretty tangent. It looks so tangent that they're basically on top of each other. That's encouraging. It also intersects at the point of interest, 2, negative 3. The green is our parabola. That's what's inspiring our tangent lines. And wow, it seems that we have a complete answer for this question. We have our two equations for the tangent lines to this parabola that intersect with our point of interest, 2, negative 3. So when we look through the solution here, well, the solution is incomplete. We have the derivative, which is an important part of this, but finding the derivative is the first step. Then you need to consider, the derivative is going to give us the slope, and we need that slope to be equal to the slope that we would get if we were to like make a line with a point on the parabola and the point of interest P. Those slopes have to line up. So we made our point on the graph, which is just x, and then its y component, which is x squared plus x. That's the equation for y. And our point P, we found the slope between those two by doing, we treated point P as our destination and our starting point as like the point on the graph. And we used our slope equation to slide that in. We equated our calculated slope between P and the point on the parabola. We made that equal to the slope that we would get from the derivative, 2x plus 1. Since they were equal, we can do some rearranging, some mathematic magic, expand them out, multiply them together, make them a single quadratic, make it equal to 0. We could have used quadratic formula. It's perfectly valid to use quadratic formula, but sometimes you get nice numbers like this like -5 and -4. So we know that we multiply +1 or x plus 1 and x minus 5. That will give us this. Try it out. I bet you'll get it. That tells us that the points of interest that give us tangent lines that intersect with point P, point of interest P, 2, -3, those tangent lines occur at x equals 5, x equals -1. So that transforms, once we know those, that transforms the question into find the equations for tangent lines at x equals 5 and x equals -1, knowing point P and knowing this. So we find the derivative, and then we found the equation of the line by first finding the slope, subbing in a point for x and y. We use point of interest P, but if you did not have a point of interest P, you could just use like the actual equation to solve for a point here. Like you would solve in any x, or the x at that particular point, as well as the y at that particular point. You would need to solve for it. We solve for our base values, our b values in our equations of a line. Once we have that, we can finish and finalize our equations for the tangent lines that intersect with our point of interest, point 2 and -3. And that is our complete solution to the answer to the question. Find the equations of the two lines that pass, the two tangent lines that pass through the point 2 and -3 that are tangent to the parabola x squared plus x. Sounds groovy, super groovy. So a comment on the solution is that the solution is incomplete. Need to use the derivative to equate to the slope of an arbitrary point. Arbitrary. Yep. Good thing I'm teaching math instead of spelling. Not economics either for selling, but yeah. Yeah, for the slope of an arbitrary point and point 2, -3. This will lead to a quadratic giving x values for where the tangent lines will intersect with point 2, -3. Then solve for the equation of the tangent line at those x values solved for earlier. Looks good. And that would conclude this question.